In this next proof, it mentions an angle, so we're definitely going to need to draw a picture. So step 1, here's a magic secret. I snipped the given so I wouldn't have to rewrite it, but I'm going to copy the given down exactly as I see it. That's my first statement. So D is in the interior of angle MAT. I am going to draw angle MAT. A is my middle letter, so that means that A is the vertex of that angle. That's an A. It's a really ugly A. And T, MAT. So here's angle MAT. A is the vertex, and D is somewhere in the interior of that angle. So I can draw that ray AD, and I've just created 2 angles. So or 3 angles. So if I had just given you this picture and I said write a conjecture based off of this picture, you might think, oh, part plus part equals whole. This angle plus this angle is equal to the whole big angle, angle MAT. So that's my second statement. The measure, that's an M. The measure of angle MAD plus the measure of angle DAT is equal to the whole enchilada, the measure of angle MAT. That reason part plus part equals whole, these are angles. I am adding my angles together. That is called the angle addition postulate. Angle addition postulate. Sorry, my touch screen is not working today. Angle addition postulate. That's so ugly. It's a little better. Part plus part equals whole. So I set up my equation with angles. Now I can go take all of these expressions and plug them into the correct spot. So the measure of angle MAD is 41 minus 3x. The measure of angle DAT is 16x plus 1. And the measure of angle MAT is 19x. So when you're plugging things into the right spot in the equation, that is the substitution property. So notice, first I set up my equation with just angles. Then I went in my next step and substituted all of the expressions in to the equation with the angles. So on step 4, the next step, I need to combine like terms because I'm trying to solve for x. So negative 3x and positive 16x is 13x. 41 plus 4 is 42 equals 19x. So I'm allowed to just combine all my like terms in one step. I can combine my variables and my numbers in the same step, and that is called simplify. When I'm just combining like terms, simplify. Now I want to get all my x's on one side, so I'm going to subtract over the 13x. So that will give me 42 equals 19x minus 13x is 6x. So that's the subtraction property. Then I want to divide by 6 on both sides to get the x by itself. So I'm going to divide by 6 to get 7 equals x. And that, when I'm dividing on both sides, that's the division property. Sorry, it's getting a little squished in here. That's the division property, 7 equals x. So you might be thinking, okay, I solved for x, I'm done with my proof, but gotta go check my proof statement. My proof statement says x equals 7, and my last step says 7 equals x. So it doesn't match perfectly, so I'm not done. So step 7, I gotta switch it. X equals 7, and when I switch the left side of my equation with the right side of my equation and the right side with the left side, that is called the symmetric property. That is the symmetric property. And now we're done.